Hello my friends, and welcome back to KrossUSA channel. Today we're taking you on a journey through some of the most impressive wood processing operations around the globe. For those of us who remember when American sawmills dotted the landscape from Maine to Oregon, today's video will remind you of the incredible ingenuity that goes into processing the wood that surrounds us every day. So grab your coffee, settle in, and let's explore the remarkable world of modern and traditional lumber production. Our first stop takes us to Germany, where precision engineering meets centuries of woodworking tradition. Here at Wilson GmbH, we witness something truly spectacular, a complete softwood processing line that handles those long, slender coniferous logs measuring 1.2 meters in length with the kind of efficiency that would have amazed the lumber barons of the early 1900s. What makes this operation particularly fascinating is their complete commitment to Link Machinery, a German company that's been perfecting sawmill technology since 1869. To truly appreciate what we're witnessing, let me share the remarkable story behind Link. Founded by Johann Friedrich Link during the dawn of Germany's Industrial Revolution, this company began in an era when sawmills were still powered by water wheels and steam engines. Link witnessed the American timber boom of the late 1800s and recognized that European sawmill technology needed to evolve rapidly to compete with the massive operations emerging across the Atlantic. By the 1880s, Link had revolutionized European sawmill design with innovations that included the first commercially successful circular saws capable of handling large diameter logs, technology that American lumber companies quickly adopted. NTHE engineering philosophy behind Link's success lies in their understanding of what foresters call fiber utilization efficiency, essentially, getting the maximum amount of usable lumber from every tree harvested. This concept became critical during World War I, when European timber resources were stretched to their limits, and again during the post-war reconstruction, when efficient lumber production was essential for rebuilding entire cities. The 1.2 meter length specification we see here isn't arbitrary. It represents the optimal balance between handling efficiency and yield maximization for Central European softwood species like Norway spruce and Scots pine, which have different growth characteristics than the massive Douglas firs and redwoods that dominated American lumber production. The process begins with log preparation, where each piece of timber is carefully positioned and oriented. The Link system uses advanced scanning technology to determine the optimal cutting pattern, something that old-time sawyers did by eye and experience. These scanners represent a fascinating convergence of technologies that didn't exist when most of us were young. They combine laser measurement systems originally developed for precision manufacturing with X-ray technology adapted from medical imaging, creating a three-dimensional map of each log's internal structure. This scanning can detect not just visible knots and grain patterns, but also internal defects like heart rot, compression wood, and even the subtle density variations that indicate how a tree responded to wind stress during its lifetime. Numbered the logs enter the primary breakdown area, we see the heart of the Link system at work. The main circular saw, running at precisely calculated speeds, makes that first critical cut. The sound is distinctive, a clean, powerful whine that speaks to German engineering precision. These saw blades represent metallurgical achievements that would astound the toolmakers of earlier generations. Modern sawmill blades use what's called stellite tipping, cutting edges made from cobalt chromium alloys that maintain their sharpness through thousands of cuts, while operating at blade tip speeds exceeding 150 miles per hour. The blade geometry is calculated using computer modeling that considers factors like wood density, grain orientation, and even seasonal moisture variations that affect cutting forces. NTHE beauty of this system lies in its integration. As each log passes through the primary saw, automated conveyors, another Link innovation, transport the resulting cants to secondary processing stations. Here's where it gets really interesting. The system can simultaneously process multiple pieces, with each cant following its predetermined path based on that initial scan. This parallel processing concept revolutionized sawmill efficiency in the 1990s, when computer control systems finally became sophisticated enough to track individual pieces through complex manufacturing processes. NTHE secondary breakdown involves multiple smaller saws working in perfect harmony. Edge trimmers remove bark and irregular edges, while optimizing saws cut each piece to exact dimensional lumber standards. What took a team of skilled sawyers an entire day in 1950 now happens in minutes with remarkable consistency. The precision is remarkable. We're maintaining dimensional tolerances of plus or minus 1 millimeter across lumber that will eventually be used in applications ranging from traditional house framing to engineered wood products for modern skyscrapers. The final stage involves precision grading and sorting. Modern lumber grading combines computer vision with traditional lumber grading principles that haven't changed much since your grandfather's time. The difference is speed and accuracy. This link system can grade and sort lumber faster than the human eye can follow, yet maintains the quality standards that built America's homes for generations. The grading algorithms incorporate over a century of accumulated knowledge about how wood characteristics affect structural performance, combined with modern understanding of wood mechanics that allows engineers to predict exactly how each piece will perform in service. Watching this Yules in operation, you can't help but marvel at how German engineering has elevated what was once pure craftsmanship into a science, while still respecting the natural characteristics of wood that make each piece unique. Now, let's step back in time and witness something that connects us directly to our industrial heritage. This magnificent machine before us is a line Pirna frame saw from the last century, a mechanical marvel that represents the pinnacle of pre-electronic sawmill technology. NFOR. Those of you old enough to remember the distinctive rhythm of old sawmills, this machine will bring back memories. The Line Pirna company, based in what was once East Germany, built these frame saws to last generations. This particular model, with its massive cast iron frame and precisely balanced reciprocating mechanism, embodies the kind of craftsmanship that made German industrial equipment legendary worldwide. And watch as this substantial log is positioned in the saw's path. The setup process alone is a testament to old-world precision. Unlike today's computer-controlled systems, this machine requires the skilled eye and experienced hands of a master sawyer. The log must be perfectly aligned, taking into account grain patterns, potential defects, and the desired end products. NTHE frame saw operates on a beautifully simple principle that hasn't changed since the 1800s. That massive frame, weighing several tons, moves up and down in a perfectly vertical motion. The saw blade, stretched tight within the frame, cuts on the downward stroke. The rhythmic motion, up and down, creates that hypnotic sawmill cadence that once echoed through America's lumber towns from dawn to dusk. What's remarkable about this Line Pirna machine is its precision. Despite being decades old, it can cut lumber to tolerances that rival modern equipment. The secret lies in the mechanical engineering. Every bearing, every guide, every adjustment mechanism was built to craftsman standards that seem almost extinct today. Notice how the log advances automatically between cuts. This feed mechanism, all mechanical with no electronics, demonstrates the ingenious problem-solving of earlier generations. Springs, cams, and precisely calibrated weights work together to move the log exactly the right distance for the next cut. This single cut we're witnessing might take several minutes compared to seconds on modern equipment, but there's wisdom in this slower pace. The blade stays cooler, the wood experiences less stress, and the resulting lumber often has superior characteristics for certain applications. Welcome to one of Europe's most sophisticated lumber processing operations, Gebr. Hosenfeld. This family company, with roots stretching back generations, represents the perfect marriage of traditional German woodworking expertise with cutting-edge link sawmill technology. And what makes this operation truly special is their unique integrated system. Unlike conventional sawmills where different processes happen in separate locations, Hosenfeld has created what we might call a lumber factory, where raw logs enter one end and finished, graded lumber emerges from the other in a continuous, highly orchestrated process. Let's start with their remarkable link saw system. Now, Link has been perfecting sawmill technology since before the American Civil War, and this installation represents the culmination of over 150 years of engineering refinement. But here's what makes the Hosenfeld setup unique. They've integrated a profiling machine directly into their primary saw unit. This integration represents a breakthrough in what sawmill engineers call single-pass processing, the holy grail of efficient lumber production. Traditional sawmills required multiple handling steps to transform logs into finished dimensional lumber, with each handling operation introducing opportunities for damage, misalignment, and quality degradation. And watch as this first log enters the system. The initial breakdown happens exactly as you'd expect. The main circular saw, running at optimal speeds, makes those primary cuts that transform a round log into manageable cants. But here's where things get interesting. Instead of sending these cants to a separate profiling station, Hosenfeld's system includes an integrated profiler that begins shaping the lumber during this first pass. The cutting heads used in this system represent remarkable engineering achievements. Each profiling head contains multiple cutting edges made from polycrystalline diamond, synthetic diamonds created under extreme pressure and temperature conditions. These cutting edges can maintain their sharpness through millions of linear feet of cutting, while producing surface finishes smooth enough for high-end architectural applications. And this integration eliminates handling time and reduces waste, two factors that separate profitable operations from those that struggle. Every minute saved in material handling, every small improvement in lumber yield, adds up to significant advantages in today's competitive market. The economic impact is substantial. Traditional sawmills might achieve lumber recovery rates of 45 to 50% from raw logs, while integrated systems like Hosenfeld's can reach 65 to 70% recovery, a difference that translates to millions of dollars annually for large operations. Now, here's where the real innovation shows. On the second pass through this integrated system, the profiling process completes its work. This isn't just about cutting lumber to dimension. It's about creating precisely profiled products that meet exact specifications. The profiling heads, manufactured to Link's exacting standards, can create complex profiles that would have required multiple separate operations in traditional mills. Modern profiling systems can create over 200 different standard profiles, from simple construction lumber to complex architectural moldings, all from the same basic equipment configuration. NTHE lumber emerging from this second pass moves seamlessly to what many consider the heart of any modern sawmill operation, the edge trimming system. This Hosenfeld installation uses optimizing edge trimmers manufactured by EWD, which is part of the Link family of companies. These aren't your grandfather's simple trim saws. These are computer-controlled precision instruments that represent the convergence of multiple advanced technologies. The optimization algorithms running these trimmers process over 10,000 calculations per second, evaluating factors including defect location, grain orientation, market value of different lumber grades, and even current inventory levels to determine the optimal cutting strategy for each individual piece. Each piece of lumber is individually scanned as it approaches the trimmer. High-resolution cameras and laser measurement systems evaluate the edges, looking for defects, irregularities, and opportunities to maximize value. In microseconds, the computer calculates the optimal trimming strategy, where to cut to remove defects, while maximizing the useful lumber yield. The scanning technology combines visible light imaging with near-infrared spectroscopy, which can detect internal defects and moisture variations that aren't visible to the naked eye. One of the most impressive aspects of this Hosenfeld operation is the blade-changing system that Link has perfected. In traditional sawmills, changing saw blades could take hours and require shutting down entire production lines. The economic impact was enormous. A major sawmill might lose $10,000 minus $20,000 in production for every hour of downtime. Here, with Link's double arbor quick change system, blade changes happen in minutes. This innovation draws from Formula One racing technology, where pit crews must change tires in seconds while maintaining perfect precision. Watch this process carefully. The double arbor design means there's always a sharp blade ready to take over. When blade change time comes, the system smoothly transitions from the working blade to the standby blade. Meanwhile, the dulled blade can be removed, sharpened, and replaced, all while production continues uninterrupted. The blade sharpening process itself is automated, using computer-controlled grinding wheels that restore each blade to factory specifications. NNTHE lumber sorting and grading area showcases another aspect of modern German efficiency. Computer grading systems work alongside human expertise to ensure consistent quality. Each piece is evaluated for strength characteristics, appearance grades, and dimensional accuracy before being sorted into precise product categories. What's particularly impressive is how this system handles the natural variations in wood. Unlike manufactured materials, every piece of lumber is unique. The grain patterns, knot structures, and natural characteristics that make wood beautiful also make it challenging to process consistently. The Hosenfeld system embraces these variations, optimizing each piece individually rather than treating all lumber identically. NTHE final packaging and shipping area reflects the same attention to detail we've seen throughout this operation. Lumber is bundled according to customer specifications, with careful attention to moisture content, dimensional consistency, and grade uniformity. This isn't just about moving product, it's about delivering exactly what customers ordered, when they need it. And standing in this facility, watching logs transform into precisely manufactured lumber products, you can't help but appreciate how far the industry has evolved, while still respecting the fundamental nature of wood as a material. This is what happens when traditional craftsmanship meets modern engineering. Efficiency that would astound our predecessors, combined with quality standards that honor the material itself. Now we turn our attention to a different type of wood processing innovation, the log cut MCS40, a machine that represents a fascinating approach to modern log processing. Log cut has carved out a unique niche in the industry by focusing on versatile, efficient systems that can handle a wide variety of log sizes and species. NTHEMCS40 embodies what we might call smart simplicity. It's sophisticated enough to deliver precise results, yet straightforward enough to operate reliably in demanding production environments. For those of us who've seen countless pieces of industrial equipment over the years, there's something refreshing about a machine that does its job without unnecessary complexity. NNTHE log handling system showcases thoughtful engineering. Unlike massive systems that require enormous logs to be economical, the MCS40 can efficiently process a wide range of log diameters. This versatility matters tremendously for smaller and medium-sized operations that don't have the luxury of processing only premium logs. And watch as this log enters the positioning system. Hydraulic arms gently but firmly secure the log, while measurement systems determine the optimal cutting strategy. The positioning is critical. Even small variations in log placement can significantly affect lumber yield and quality. NTHE cutting mechanism itself demonstrates modern precision engineering. The saw head assembly can be adjusted quickly to accommodate different cutting patterns, different log sizes, and different product requirements. This adaptability is what separates modern equipment from the single-purpose machines of earlier generations. What's particularly impressive about the MCS40 is its feed system. The log advances through the cutting zone with remarkably precise control. Each increment of movement is calculated to optimize the cutting pattern for that specific log. This level of control was simply impossible with the mechanical systems of the past. It requires the integration of hydraulics, electronics, and computer control that has revolutionized modern manufacturing. NTHE cutting action demonstrates the precision that modern sawmill equipment can achieve. Each cut is clean, accurate, and consistent. The saw blades, manufactured to exacting specifications, maintain their cutting performance through extensive use. The result is lumber, with smooth surfaces and precise dimensions that meet today's demanding construction standards. One aspect that particularly impresses me is the machine's efficiency in handling varying log quality. Not every log is perfect. Nature doesn't work that way. Some logs have knots, some have irregular shapes, some have internal defects that aren't visible from the outside. The MCS40's scanning and optimization systems can adapt to these variations, maximizing value from each piece of raw material. NTHE waste handling system reflects the same thoughtful engineering we see throughout the machine. Sawdust, bark, and trim pieces are efficiently collected and conveyed away from the cutting area. In modern operations, these waste products often become valuable co-products. Sawdust for paper production, bark for landscaping mulch, and trim pieces for engineered wood products. NTHE control system interface shows how far industrial automation has evolved. What once required years of experience to master can now be learned relatively quickly. The computer handles the complex calculations, while the operator focuses on quality control and system optimization. It's a perfect example of technology augmenting human capability rather than simply replacing it. Watching the MCS-40 in operation, you appreciate how modern equipment can maintain production flexibility while delivering consistent quality. This machine can switch between different products, different cutting patterns, and different log sizes with minimal setup time. That flexibility is crucial in today's market, where customer demands can change rapidly and raw material availability varies seasonally. Now, for many of us who remember splitting firewood by hand with mauls and wedges, this machine represents an almost magical transformation of a labor-intensive process. The Posch company, based in Austria, has built their reputation on creating equipment that brings industrial efficiency to traditional wood processing tasks. The NTHE Spaltfix K660 Averio embodies what we might call purposeful engineering. Every component is designed specifically for the demanding task of splitting logs into consistently sized firewood pieces. The Averio designation refers to the machine's ability to automatically adjust to different log sizes and split patterns, eliminating the constant manual adjustments that characterize simpler equipment. And watch, as this substantial log is positioned in the machine. The hydraulic system, the heart of any modern log splitter, generates tremendous force with remarkable precision. We're talking about splitting forces that would require multiple strong workers with traditional tools, delivered consistently, safely, and with perfect control. NTHE splitting mechanism demonstrates sophisticated engineering. Multiple splitting wedges work in sequence, transforming a whole log into perfectly sized pieces in a single cycle. The wedge design itself reflects decades of refinement. The angles, the steel composition, the surface treatments, all contribute to efficient splitting with minimal wood fiber tearing. What makes this machine particularly impressive is its adaptive capability. The Averio system automatically adjusts the splitting pattern based on the log's characteristics. Harder woods require different splitting strategies than softer species. Logs with knots or irregular grain patterns need special handling. The K660 Averio recognizes these variations and adjusts accordingly. NTHE conveyance system showcases the kind of integration that separates professional equipment from simple machines. As each log splits, the resulting pieces are automatically sorted and conveyed to collection areas. This eliminates the manual handling that makes firewood production so labor-intensive when done with traditional methods. Run watching the Posch Spaltfix in operation, you can't help but appreciate how modern engineering can transform even the most traditional tasks. This machine doesn't just split wood faster. It does it better, more consistently, and with far less physical demand on the operator.